All right, guys, we're going to talk about quadratic functions. So this is the first lesson of Unit 2. So quadratics are a part of family of functions called polynomials. So you can read a really formal definition of polynomials here. We'll kind of go through it. So it says, let n be a non-negative integer, and let a sub n minus 1, and so on, be real numbers where a sub n cannot equal 0. And then this function will be a polynomial function with a degree of n. Really what we're looking at is we have x to some power. That power is decreasing by 1 every time. In a polynomial function, we could skip over one of these powers, meaning we might not have like an x to the third term or an x to the fifth term. We might skip over it. That's fine. It's still a polynomial. And then we have these a sub n minus 1, all the way down. Those are just the coefficients. So, we could have something that looks like this, like a function f of x could be 3x to the 9th minus 7x to the 8th. Notice the power is decreasing by 1. But we could skip over 1 or 2 or more. We could say, I don't know, plus x to the 5th, or we actually skipped over x to the 7th and x to the 6th, and keep going from here. Whatever we really want. This is a polynomial function plus x minus 10. So here's a polynomial function, not really one where you're going to be working with. 9th degree is pretty high degree. It's things get pretty complicated around here, but still a polynomial function. All right, and quadratics are the ones that we're going to be focusing on. So quadratics, remember, are x squared. Okay, so here we have some examples of polynomial functions. These are all f, but it could be any function name. I want to look at a few things. Notice how we have distinct terms separated by pluses and minuses. We have a bunch of different types of polynomials. Let's go ahead and check out the degrees of these polynomials. And the degrees often have special names associated with them. So the degree is going to be our highest exponent power. So this is a degree 3 polynomial, or third degree, however you want to say that. And we have a special name for that one. We call it a cubic, because cubing is raising to the third power. This one here is a degree 1 polynomial. More commonly, we would probably call this a linear function. Linear. If we graphed it, it would make a straight line, right? Straight line of some sort, even with a slope and a y-intercept and all the things we know about linear functions. Here is what we're going to focus on in this section, a quadratic, or degree 2. So remember, quadratics make parabolas, so we're going to be looking at a lot of parabolas today. I didn't say what cubics make. They make this kind of like squiggly graph, something like that, with kind of 2 curves to them. And then here is a 5th degree polynomial, or degree 5. All of these, they were written in descending order, highest power, then next highest, then next and next, all the way down to the constant term here, the last one with no x at all. That's standard for polynomials. That's the way they should be written, but they could be written in a mixed up order, and you would want to identify the highest power for the degree. Now, there's probably a special name for this. It's probably something like a quintic polynomial, but we're not going to be using that word really, so I don't really care that you know that one. But these other ones, cubic, linear, I guess I didn't write this down, but quadratic, we need to know those names. All right, let's go ahead and keep moving forward. All right, so a quadratic function, this is called standard form. We have a, b, and c, which are just some real numbers. These are the coefficients, or the constant term for our quadratic. And notice we have x squared, x, and then no x at all. This is our basic quadratic function in standard form. Hopefully remember that quadratic functions make parabolas. And so looking at the equation of a quadratic in standard form like this, we know whether it's going to open up. If the a value right up here, if this is positive, it's going to be opening upward like this, or if the a value is negative, it's going to be opening down. Some important features of quadratic graphs would be the vertex. We'll We'll talk a lot about the vertex and also the axis of symmetry. All parabolas are symmetrical through that vertex. So these parabolas are all going to have a vertical line of symmetry. You probably learned in Algebra 2 about some horizontal parabolas, but those wouldn't be functions, so we're not going to be focusing on them in this section here. All right. Again, standard form right here, ax squared plus bx plus c. This is our function standard form. It's f of x. In an equation, if it's a quadratic equation that you're trying to solve, standard form involves equaling 0. So you want to make sure one side is 0 if you have a quadratic equation, which we will look at some of those here and there throughout the section too. All right, so this is a small distinction. So for some reason, our textbook calls this standard form, but that's really out of the norm. I've never heard that used before. I'm going to call this graphing form. And the previous one, which is always called standard form, I'm going to call that standard form. So this is graphing form. And the reason it's called graphing form is because it tells us some important features of our graph right off. It tells us the vertex right here and here, this h and k. H will be the horizontal or the x coordinate of our vertex, and k will be the y coordinate of our vertex. Going back to transformations, remember, since this h is being subtracted here on the inside, that causes a horizontal transformation, therefore shifting the graph horizontally and changing its vertex location according to this value. And also, like that horizontal transformation, it's kind of the opposite of what you think. So if this was x minus 2, even though it's minus 2, my x coordinate for my vertex would be a 2. And if this was plus 3, just like a vertical shift where it's added onto the end, plus means up. So this would be a 3 for my vertex there. Now, if this was different, if this was plus 2 instead of minus 2, then it'd be a negative. Because remember, if we're adding 2 to the inside of a function, that causes a shift to the left, and left is negative on our x-axis. So got to pay attention to that. Is very similar to horizontal transformations that we talked about last chapter. All right. And then the other thing we have in this form is the a value. This a value is the same as the a value on the other one. If it's greater than 0, meaning it's positive, our parabola will open upward. So parabola opening upward. And if it's less than 0, meaning negative, that means our parabola will open downward. There are some other things that a can tell us, right? This is a stretch as well. So if this value is like a 2, that means we'll have a narrower parabola. Whereas if this is like a fraction, like a 1/8 or something like that, we'll have a much wider parabola. So the a value can tell us a lot about the general shape, the direction, and kind of the general shape, whether it's been stretched or shrunk down, squashed in a little bit. Okay, so this is saying that a is greater than 1, and this is saying that a is technically between 0 and 1, but something like a 1/8 would make this graph, and something like a 2 might make that graph. Okay, let's go ahead and keep moving forward. All right, so here is our parent function, f of x equals x squared. That's our basic parent parabola. And then we have this one here. And I'm going to think about it both in terms of the HK definition that we just had. So this is the H, and this is the K. Remember, the H is kind of the opposite. So our vertex here is actually at -3. And then -2 is -2. So we can think about this vertex being transformed, being moved based on the transformations that are happening. We added 3 on the inside, which caused a shift to the left 3. 1, 2, 3. And we subtracted 2 on the outside, which means we shifted down 2. 1, 2. So that's how we ended up with our vertex moving that much and ending up in this place. I like to connect it to the things that we've done in the past. Hopefully that helps. So we were shifted, what is that? 3 to the left and 2 down. All right, so let's go ahead and look at these really quickly, and let's try to find the vertices. Of course, I didn't do that right. Okay. Let's find the vertex of each of these. Okay, so we have our h and our k. So remember, h is always kind of the opposite of what it appears here. Since we're subtracting 4 on the inside, that actually moves to the right. So that makes that a positive 4, positive 3. Feel free to pause and do these real quick if you want to check your answers there. Again, the opposite, so this is a -5 and a positive 1. Opposite again, so this is 8 and -6. Only that h value is the opposite. And again, that goes back to our horizontal shifts that we learned about last chapter. So these should be our vertices, our vertexes. I don't know what the proper word is there. All right, completing the square. I'm not going to get into depth here about what's going on in this whole process. Feel free to look it through and kind of compare it to these steps. I'm really just going to focus on what the steps are. So, and I'm going to go through the examples on the next couple slides. So, we put it in standard form. We have to factor out any a value. So that's an important step. Then we'd have to do this, figure out what b over 2 squared is. And that's going to be added. The whole point of completing the square is to get it into that one format, right? That graphing form, a x minus h squared plus k. So just kind of looking at the things that are going on, that first thing of factoring out that is giving us the a value. And then kind of leaving out this, that's going to end up contributing to the k value. So we're already kind of, starting to make it look that way, where we've got, this isn't the whole k value. There's going to be more stuff that we do to it that ends up out here. And then what we're doing is we're manipulating this quadratic that we have in here. We're going to end up putting something here so that it factors in this nice special way. We don't know what h is going to quite be yet, but we're going to add something to this so that it happens, so that we get this special type of factoring. It's all about manipulating this equation to kind of turn it into this graphing form. And you can kind of follow through the steps here and see what's going on. I found this confusing when we were going through it in class, just because people seem to be lost a little bit. So I want to just kind of do a little bit of an easier example on the next slide to get through this. Okay. Yeah. Again, feel free to look through this and go back to it if you need. But right now, I'm just going to kind of actually do one of the examples from the beginning. So let me clear that. Okay, so we have our quadratic. It is in standard form. So the very first thing I need to do is, one, kind of change the setup of it, and I also will have to factor out this a value. But I'm really only going to factor it out from the first two terms. I'm already kind of leaving that on the outside, and that's going to end up being our k. So if you remember what our goal is something like this. So that 7 that's on the outside, that's going to contribute to the k value. And when I factor this out, that's going to end up being my a value. So I'm already getting along on my way. So I need to factor away a 2. So I end up with x squared plus 4x plus, now I'm going to leave a blank spot. This is where I'm going to create something that gives us this special factoring. And that plus 7 will still be there. So here's where we're at after our first step. Okay, so we want this inside of here to end up being a perfect square trinomial. So we want it to factor so that it's going to be x minus h times x minus h, so that we can rewrite it as x minus h to the second power. And so the trick to that, it's not really a trick, I don't like using that word, but the way we do this is we have to think about the way these things multiply together. They end up multiplying as x squared minus 2xh plus h squared. So this middle term is kind of what we're looking at right here. And we need it to kind of turn into that. So the way we do it is we take this middle term and we divide it by 2, just the coefficient, so 4. We always do b over 2 squared. So that's going to be 4 over 2 squared. So 4 divided by 2 is 2, squared is 4. So we're going to be adding 4 to this function. This is being added out of nowhere. It's not part of my original function, so that's a bit of an issue, right? I'm not allowed to just add something in there because then it's no longer equivalent to this thing. That's like if I just added 4 to it. Well, actually, I didn't just add 4 to it. Actually, a little more complicated than that, because technically I added 2 times 4, because it's inside the parentheses, and the distributive property would tell me that this is eventually going to get multiplied by that 2. So I added 8. Not allowed to just do that. I can't just add 8 out of nowhere, but I can do it if I counterbalance it, if I also subtract 8. So I added 8 right here. Really is 4, but 2 times 4 is 8. I also have to subtract 8. So that's what I'm going to do. That keeps it balanced. Whatever I added right here, I have to subtract right here. Okay. Now it's equivalent to that original function. I didn't add anything there that wasn't there before. So that's cool, and now I can start factoring this. So this quadratic on the inside, remember I'm looking for 2 numbers that multiply to 4 and add to 4, 2 and 2. So that tells me that this quadratic factors as x plus 2 times x plus 2, or x plus 2 squared. That's what we're looking for right there. So x plus 2 squared. And then I need to put these together, plus 7 minus 8, minus 1. So then we have achieved the graphing form right down there. And that was our goal, was to get graphing form. It really hinges on this identifying what I need to add in there, subtracting the same amount on the outside, and then simplifying this all down into the proper graphing form. Let's do one more. Let me clear this off. So let's do one more. Here is another one. I don't know what color is best here. I'm going to try this. Okay. So again, whoop. Okay. All right, so same idea. I'm gonna group these here together. I need to factor out this. If there's no number here, I can kind of skip this initial part, but I'm gonna be factoring 3 away from these. So it's gonna be x squared plus 8x plus something. I'll leave that open blank there, and then I put that 33 on the outside. So this is our first step. Then we need to figure out what's gonna go in here. So we take b over 2 squared. So that's 8 over 2 squared. 4 squared, 16. So I added 16, but we need to be careful. I'm not only adding 16, I'm actually adding 3 times 16. 3 times 16 is 48. So since I added 48, I need to subtract 48. Because adding and subtracting, those cancel each other out. It's equivalent now. And we've basically done everything. This is it. I now just need to do some simplifying here involving factoring this and then putting these 2 terms together, and I'll end up with graphing form. So let's start with the factoring. So with the factoring here, I need 2 numbers that multiply to 16 and add to 8. That's going to be 4 and 4, which again means this is going to factor as x plus 4 times x plus 4, or x plus 4 to the 2nd power. Now I need to bring down that 3 that I factored out earlier. And I need to put these together, which is going to be negative 15. And so here we go. Here's our function in graphing form, vertex. Our vertex, we could even look at that and identify it. It's going to be negative 4 comma negative 15. Not too hard, although it is tricky. There's lots of little spots here to do some intricate little things that if you don't fully comprehend it, you're not going to be able to execute it. So you got to really know the process that's going on. Okay, I'm going to try one more that does not have a coefficient here. So I'm just going to make something up and kind of go through it real quick. All right, so let's say we had, we'll call it g of x for difference. X squared minus, we'll do 5x plus 1. Okay, so no coefficient here, so I'm just going to do a little grouping. X squared minus 5x plus something plus 1. I didn't have to factor that out, so there's nothing here. I mean, technically there's a 1, I suppose, so our a would be 1. Now I need to figure out what needs to be added in there. So remember, I always got to do b over 2 squared. So my b is now a negative 5. This is something that can happen, is anytime we have an odd number there, since I'm going to do b over 2 squared and b is an odd number, I'm going to get a decimal or a fraction. It sort of depends. So I could do this as 2.5 squared, I guess negative 2.5 squared, or I could keep this in a fraction and get 25 over 4. Doesn't really matter which way I go with it, since this decimal is a terminating decimal and it would be okay. I'm going to go ahead and use the decimal version for now. So that's going to give me 6.25. So that's what I need to add here. And I need to subtract here. Now this one's different, right? Because there's no number here. So I am actually only adding 6.25. If there was some a value, I would need to multiply that and then subtract that amount off on the end here. But since I just only added this amount, I can subtract it right there. Okay. How in the world is this factor? I need two numbers that multiply to 6.25 and add to negative 5. Well, I know it's the same number here and here. So I'm essentially saying, all right, what number squared gave me 6.25? And those should add up to that. Well, I can just do the square root of this. But also, if I look right here, didn't I just square this to get 6.25? So it's going to be negative 2.5. In fact, this number, half of this number, is always the way this factors. So half of negative 5 is negative 2.5. It always is going to factor as x minus b over 2. Or sorry, x plus b over 2 squared. And in this case, it's negative 2.5. Okay. Running out of room a little bit, but that's okay. Putting these together, I'm getting negative 5.25. And that factored as x minus 2.5 squared. And we call this g of x. So there is our vertex, 2.5 comma negative 5.25. That would be our vertex from here. This is graphing form. It's the same process every time. There's some intricacies that you got to get used to. So doing it a bunch of times is helpful. Obviously, I've done it a lot, so it's not too hard. Okay. I'm going to go ahead and stop right there. I'm going to make another video about the different factoring methods, so I'll see you then.